Hello everyone, I hope you guys are well. Today I like to talk about lamps. So let's start discussing lamps. First of all, what is lamps? Lamps is a molecular dynamics code that is written in C language. It models an ensemble of liquid, solids or gaseous particles. It can be used on a laptop, but it is basically designed for a parallel computing. So what it does? Actually, it integrates Newton's equation of motion for a collection of interacting particles. A single particle can be a atom, molecule, electron, or you can even model a coarse grain model of atoms, and continuum and mesoscales are also supported in this code. So what LAMMPS feature does it offer? There are various LAMMPS features that it offers. For example, labs can be used to run on a single process or in parallel. It offers many particles and model types. For example, it can allow modeling of atoms, molecules, polymeric systems, and others continuum systems. Apart from that, it offers lots of force fields built in into the MD. LAMP supports various kind of interatomic potentials such as pairwise, many-body, and modern machine learning models. LAMPS gives the luxury to create atoms on the spot or read data files generated from other packages. So we can create atoms on will, or we can read atomic data from other files generated by the other packages such as PDB format. LAMPS also offers 2D and 3D modeling with various options for barostating and thermostating. It allows constraints such as you can restrict an angle to some value throughout your molecular dynamics. Apart from that, it offers integrator and diagnostics, and diagnosing the molecular code is not an issue. It gives you hint about the error you made in the script. It also offers ways to write your output to a log file, or to even offers you some snapshots of the atoms. It also offers multi-replica models. For example, you can accelerate your dynamics using temperature, or you can also study hyperdynamics. And it also offers pre and post processing tools, some of which comes built in with the lamps such as pizza.py. It and there are other some specialized features which are beyond the molecular dynamics that lamps has to offer. So basically, lamps input script is typically composed of 4 parts. To implement a logic of problem, you need to understand LAMMPS script syntax. LAMMPS script can be divided into 4 parts roughly. For beginners, it is important to think of LAMMPS script structure to be composed of 4 sections. First is initialization, system definition, and simulation setting, and then comes the run part. These are the 4 sections which I like to talk briefly. In the initialization part, we generally define things that are necessary to be defined before atoms are created or read from a file. Maybe a file from generated from other software. Okay, we will see in coming slide how exactly we define these things, but for now let's understand what are the main parts of LAMP script. Second section of the LAMP script is system definition. It is all about defining the simulation cell. Well, it can be 2D or 3D, or will it be periodic or fixed boundary. So it's all about defining the system. In the initialization part, we can specify the units which LAMPS will use during dynamics. Anyway, in the third part, it is reserved specially for simulation setting. Here we define our force field parameter. Even simulation parameters can be defined here, but not limited to, because ordering of command is not important. Often, not always, but it is not important often. And in the fourth section, which is a run section, we run the dynamics. So what are the commands in LAMPS? Logic for the 4 parts of LAMP script is basically written using commands. Commands are basically function already written in C++ and serves a particular purpose when called. For example, command can be used to set an internal variable, read in a file, or run a simulation. So commands to rule them all. So there are basically 3 types of command in LAMPS. There are commands that change the local setting. For example, time step command can change the time step dynamics that it takes to jump from the one step to the next. For example, 0.5 femtosecond. Another command includes thermo and restart command, for example. The second important group of command is those that add, modify, or remove or replace styles. These are generally called style commands that execute a run. For example, there are pair style, fix commands, compute, for example. And the third category of commands is run command that performs some other computations or operation. For example, print command prints something on screen or to a file. And another example can be a minimize or run command. So we can categorize our commands further according to the script sections. So in the next video, I will talk about how these commands are categorized according to the input sections. I hope you enjoyed the discussion. I will see you in the next video.